Good morning, guys of grade 8. Today, inshallah, we're gonna complete what we started yesterday. Yesterday, we started talking about chapter 3, section 1, what is a mineral. And we agreed that mineral is a natural, solid, inorganic substance that have a certain structure or has a certain arrangement of atoms or have a crystalline structure. So that's mean any substance that already have these characteristics, we could call it a mineral. So the mineral must have five characteristics. First one must be solid. Second one that be natural. That means it's not man-made or it's not artificial. Is already formed by natural processes. Third one we said it must be inorganic. That means it's not produced by living organisms. And we said it has a certain chemical composition or certain chemical structure. And finally, the atoms of that chemical structure must be in fixed pattern or in certain arrangement when we call these crystals. So here, like this, guys, we said the geometric arrangement of the atoms of a mineral or this arrangement called crystals, and that's one of the most important properties of the mineral. The crystals even could change the characteristics or the properties of mineral completely. For example, diamond and graphite both are made of carbon, so that means they have the same chemical structure. But in case of diamond, we find that carbons are arranged in crystals in hexagon shape. So that's make diamond have its brilliant characteristics or its brilliant properties that it's too solid, okay, and or it has the most hardest or the hardest mineral ever. Plus, it's shiny, colorless, okay, and sometimes it reflects different colors and like that. So that's make diamond so expensive, okay, and too rare in the same time. While we find carbon when it arranged in form of crystals in form of sheets, okay, it formed the graphite that's which form the lid inside your pencil, okay, which is too soft, easy to be broken by your fingers, and also it's black color. It's available or it's not that rare, okay, so that's why it's not expensive. So like this we find that this completely different properties between these two types of minerals regarding to the crystalline structure of both elements, although they are made of the same chemical structure or the same chemical element or the composition. So also last time we said that the mineral could just form it of one kind of atom, or just a mineral could made of one kind of element. In this case, we call it a native mineral, or it may be made of compounds that mean a combination of different atoms, and like that's the other type of minerals. So generally today, inshallah, we're going to continue and we are going to find that, okay, minerals are classified into two major categories or two major groups. The first group, okay, that we call it, okay, silicate minerals. So what are silicate minerals? Simply, silicate minerals, they are minerals which are just made of or they contain silicon, oxygen, and the other metals, okay, or they contain other elements besides oxygen and silicon. So silicon, oxygen, and it may time contain aluminum, magnesium, potassium, or whatever this kind. So we call them silicate. So the main two elements in silicate mineral, silicon and oxygen. So once we find a mineral that contains silicon and oxygen, so classified as a silicate mineral. Actually, silicate minerals, they represent 90% of the Earth's crust. So that means they are most abundant in the Earth's crust. The other category or the other type of minerals, we call them non-silicate minerals. So non-silicate minerals, they are minerals which don't have or their structure doesn't include silicon, okay? So they may include oxygen and the other elements, but actually they not include silicon, so that's why we call them non-silicate. So the non-silicate minerals, okay, they are gonna be classified into groups or smaller groups, okay. For example, we start by the native elements. So native element, they are minerals which are just composed of one element, as we said before, like copper, gold, silver. They could found in nature as native elements. Second group, like carbonates. Carbonates, they are minerals that contain combinations of carbon and oxygen. So they made of carbon and oxygen in certain chemical structure, okay. So we call them like calcite, okay. So calcite is example of carbonate. So that's this kind of minerals, they usually used in cement and building stone, fireworks, okay, and something like that. Then we have halides. Okay, so halides are compounds that form when chlorine, iodine. They are these elements. So chlorine, bromine, iodine, bromine. They're these elements. We call them the halogens. So that's why we call this group halide. So when these elements react with sodium or potassium or calcium, the mean one of the reactive metal, they form, okay, this halides. Okay, like fluoride, for example. Okay, So they are usually are used in detergents, okay, or making detergents, and sometimes they already making in some chemical industries, okay. So the fourth group here, oxides. So oxides, from its word oxide, so it means it's just made of many elements or some mineral, metals that combine with oxygen. So like for example, aluminum oxide, iron oxide, and so on. So oxides, they are minerals that are used in aircraft parts and painting, because sometimes they are colorful, okay, like corundum, for example, that one is colorful one that used in painting, okay. So here we have sulfates. Sulfates, that's the fifth group, okay, of non-calcate minerals. So sulfate, they are minerals that form sulfates, contain sulfur, okay. So the sulfur is reacting with oxygen, or their structure contains sulfur and oxygen. So they already used in cosmetics. Cosmetics, that mean the material which you use it to take care of skin, hair, and something like shampoo and something like this. Okay, they will call this cosmetic. Also used in toothpaste, cement, and painting also, because it's already colorful. Example for sulfates like gypsum. Finally, here the last group, okay, which are sulfides and sulfates. Different than sulfides, both contain sulfur, but actually sulfates, the main structure that sulfur plus oxygen, so they have the group SO4 minus, okay, one or minus or minus two. That means they already have the negative sulfate group, while sulfides, they contain sulfur that combined with other metals like lead, iron, nickel, and something like this. So here we said that sulfides, they are make batteries, or used in making batteries. Some kinds of or sometimes they are used in medicines and electric parts. Example for sulfides like galena. So actually, guys, do we need to memorize this categories? Yes, you should know the memorize. At least you should know the chemical composition and one usage, okay, for each group of these, okay. So it's very, very important to memorize them or studying them. Inshallah, they are gonna be easy. And if you have any question, come back to me. That like that we already finished the first section, or section one. Please study well from your textbook, okay. And if you have any question, come back to me. Thank you, guys. Goodbye.